So, average atomic mass. A lot of people are used to finding an average by adding two numbers together and dividing by 2. But you're wanting to find the average of a whole bunch of atoms. And so often we think of, oh, what if this was 100 atoms? Out of that 100 atoms, how many would have this mass? And out of that 100 atoms, how many would have, what number would have this mass? So remember, one of the ways to indicate the mass of an isotope is to put a number right after the symbol. So we have these two kinds of copper, but we can't just take 63 and 65 and average them together, because the average mass is not 64. What is the average mass? Well, the easiest, the way I do, and as you remember, you've got in your notes other ways. If you're wanting to use other ways, that's fine. I usually take the mass, like 63 atomic mass units, times the percentage, 0.69. Now you notice there, I've already divided by 100, and that's just a little bit of a shortcut for you. So this is the mass divided by the percentage. The other mass is 65, and it's 31 divided by 100, 31 out of 100. So I'm just going to do 0.31. So that, to me, is the easiest way to do the work for these. So now we're going to get two numbers. I know, we got to get calculators out to a bunch of you. If you don't have a calculator on your desk, here are some that we'll pass around. Yep. And there may be calculators on a lab table close to you. We've got more calculators if you don't have one. There's more calculators. Who needs a calculator still? Okay. Right there. Anybody else need a calculator? There's still more up here. If you need one, just come on up here and grab it. So, $63 times 0.69. The mass times the relative abundance. And I'm going to write my work down at this point. I'm going to do 43.47. And I'm going to do 65 times 0.31. 20.15, and then we need to add these together. Now, is the average going to be closer to 63 or closer to 65? Well, a whole lot more of the atoms have a mass of 63. So the average is going to be closer to 63. And I'm getting 63.62. So this is how you calculate average with a relative abundance. So it's still average, but you have to remember you're averaging 100 molecules that you're using the term percentage to think about those. So here's another way of looking at this. So the isotope name, this is for gallium, and it says we have 2 isotopes of gallium. We have gallium 69, that means it has a mass of 69 atomic mass units, and its abundance is 60.11. And the actual mass, this isotope, if you're being really precise in your measurement, this isotope is actually not quite 69, it's 68.926. So we're just being really precise with our instrumentation here. This isotope of gallium, the next one we would call gallium 71. And its relative abundance is just under 40%, 39.89. And by the way, what should those abundances add up to? Always. 100. They should always add up to 100. So the actual mass of this is not quite 71. It's really 70.925. So those are the numbers where we want to work with here. So let's write down the mass of the gallium-69. That's 68.926 times its relative abundance out of 100. And you'll notice if you look back at the methods the people use in your other notes, they take this. One of the methods is to take 60.11 and divide it by 100. And I think you guys are up to just doing that in your head. 60.11, that's the abundance, 0.6011. We just divided by 100, that's out of 100. And the second isotope has a mass of 70.925 and has a relative abundance of 39.89. So let's just plug that into our calculators now. And you guys are checking my work, right? Because I could easily make a mistake with all these button pushes. 68.926 times 0.6011. And I'm getting 41.43. And 70.925 times the relative abundance divided by 100, 0.3989, 28.29. Now, when we get our answer, we're going to expect it to be between 71 and 69, right? And we're going to expect it to be closer to 69 because that has the largest abundance. So, if we add these together, Hopefully you've checked my work. I'm getting 69.72. And if you want units, those are atomic mass units. We're going to be using grams per mole most of the time. I don't tend to focus a lot on atomic mass units, but that's the mass of one atom, atomic mass units, where a proton is about 1 and a neutron is about 1, really close to 1. And so this has 69.72 as the average when you take the relative abundance into account. So there are several of these, and I'm hoping you can go through and work on all of these now. I'm going to wait until a little bit later to do this. This problem, I need to modify it a little bit to take our new 4-point grading scale into account, and I'm going to go play around with this in a few minutes on my own while you're working on other parts of the review or on other parts of the worksheet. So have fun.